Webhooks are user-defined HTTP callbacks that are triggered by specific events. They allow different systems to communicate with each other in real time, making them a powerful tool for integrating various services and applications. In the context of DevOps, webhooks can be used to automate workflows, trigger CI/CD pipelines, and facilitate seamless communication between different tools and platforms. This presentation will delve into the intricacies of configuring integration using webhooks, exploring their benefits, setup process, and best practices. At their core, webhooks are a way for an application to provide other applications with real-time information. When an event occurs in the source system, a webhook sends an HTTP post request to a specified URL containing a payload of data related to the event. This allows the receiving system to process the data and take appropriate actions. Webhooks are commonly used in scenarios where real-time updates are crucial, such as in CI/CD pipelines, monitoring systems, and notification services. Webhooks offer several advantages over traditional polling mechanisms. They provide real-time updates, reducing the latency between event occurrence and action. This leads to more responsive and efficient systems. Webhooks also reduce the load on both the source and target systems, as they eliminate the need for continuous polling. Additionally, they are relatively easy to implement and can be customized to fit specific integration needs. These benefits make webhooks an ideal choice for integrating various tools and services in a DevOps environment. Setting up webhooks involves a few key steps. First, you need to identify the events you want to trigger the webhook. Next, you configure the source system to send an HTTP post request to a specified URL when the event occurs. This URL is typically an endpoint in the target system that is designed to handle the incoming data. Finally, you need to ensure that the target system processes the data correctly and takes the appropriate actions. Proper authentication and security measures should also be implemented to protect the webhook from unauthorized access. GitHub provides built-in support for webhooks, making it easy to integrate with other services. To configure a webhook in GitHub, navigate to the repository settings and select Webhooks. Click Add Webhook and enter the payload URL, which is the endpoint that will receive the data. You can also specify the content type and select the events that will trigger the webhook. Once configured, GitHub will send an HTTP post request to the specified URL whenever the selected events occur, allowing you to automate workflows and integrate with other tools. Jenkins, a popular CI/CD tool, can be integrated with webhooks to automate build and deployment processes. To set up a webhook in Jenkins, you need to install the GitHub integration plugin. Once installed, navigate to the Jenkins job configuration and select GitHub hook trigger for GitCM polling. In GitHub, configure a webhook to point to the Jenkins endpoint. When a commit is pushed to the repository, GitHub will send a post request to Jenkins, triggering the build process. This integration ensures that your CI/CD pipeline is automatically updated with the latest code changes. Security is a critical aspect of using webhooks. Since webhooks involve sending data over the internet, it's essential to implement measures to protect the data from unauthorized access. One common approach is to use secret tokens. When configuring the webhook, you can specify a secret token that is included in the HTTP headers of the post request. The target system can then verify the token to ensure that the request is legitimate. Additionally, using HTTPS for webhook URLs ensures that the data is encrypted during transmission, providing an extra layer of security. Despite their benefits, webhooks can sometimes fail due to network issues, server downtime, or incorrect configurations. It's important to implement mechanisms to handle such failures gracefully. One approach is to use retry logic, where the source system retries the webhook request after a certain interval if the initial attempt fails. Another approach is to log the failures and notify the relevant teams so that they can investigate and resolve the issue. Proper error handling ensures that your integration remains robust and reliable, even in the face of occasional failures. To get the most out of webhooks, it's important to follow best practices. First, ensure that your webhook endpoints are designed to handle incoming data efficiently and securely. Use secret tokens and HTTPS to protect the data. Implement retry logic and error handling to manage failures. Additionally, document your webhook configurations and provide clear instructions for setting them up. Regularly monitor and test your webhooks to ensure they are functioning as expected. Following these best practices will help you create a reliable and secure integration using webhooks. Webhooks are used in a variety of real-world scenarios to automate workflows and integrate systems. For example, in a CI/CD pipeline, webhooks can trigger automated builds and deployments whenever code is pushed to a repository. In monitoring systems, webhooks can send alerts to incident management tools when specific thresholds are exceeded. E-commerce platforms use webhooks to update inventory and order status in real time. These use cases demonstrate the versatility and power of webhooks in creating seamless integrations across different systems and services. Troubleshooting webhooks involves identifying and resolving issues that prevent them from functioning correctly. Common issues include incorrect URLs, missing or invalid secret tokens, and network connectivity problems. To troubleshoot, start by checking the webhook configuration in the source system. Ensure that the URL is correct and that the target system is accessible. Verify that the secret token, if used, matches the expected value. Use logging and monitoring tools to capture and analyze webhook requests and responses. By systematically addressing these issues, you can ensure that your webhooks operate smoothly. For more complex integrations, advanced webhook configurations may be required. This can include setting up multiple webhooks for different events, using conditional logic to process data differently based on the event type, and integrating with third-party services for additional functionality. For example, you might configure a webhook to trigger a serverless function in AWS Lambda, which then processes the data and updates a database. Advanced configurations allow you to create highly customized and efficient workflows that meet specific business requirements. The future of webhooks looks promising as more organizations adopt microservices and serverless architectures. Webhooks will continue to play a crucial role in enabling real-time communication between different services and platforms. Emerging technologies such as event-driven architectures and edge computing will further enhance the capabilities of webhooks, allowing for even more responsive and scalable integrations. As the landscape of software development and operations evolves, webhooks will remain a key tool for creating seamless and efficient workflows. Webhooks are a powerful and versatile tool for integrating different systems and automating workflows in a DevOps environment. By providing real-time updates and reducing the need for continuous polling, they enhance the efficiency and responsiveness of your systems. Properly configuring and securing webhooks is essential to ensure reliable and secure integrations. By following best practices and leveraging advanced configurations, you can create customized workflows that meet your specific needs. As technology continues to evolve, webhooks will remain an integral part of modern software development and operations.